based on the market for whatever reason, they do not go forward. Anybody heard of the term called WiMAX?
New standards or upgradation of the existing standards?
Okay, so I think we have a net on that also. There you go. 63 new, 45 revisions. Yeah, so that is the ratio. How many of you have heard of WiMAX? WiMAX, yeah. So WiMAX was a technology. We invested a lot of time in IEEE to develop the technology. We lost. WiMAX lost to what was known as LTE at the time, which came from Europe. And there are multiple reasons. A lot of people swear by the technology that WiMAX is better, but it doesn't matter. Market forces drive standards. If you as a consumer do not buy a product that needs Wi-Fi or has Wi-Fi, then Wi-Fi will fail. The reason Wi-Fi is successful is because people buy it. Consumers drive that market, right? So when we talk about IEEE, a lot of people are aware of IEEE. Many may not be aware of IEEE standards, particularly from a student perspective or from academia, where they are more engaged in research and not so much on the product side of it. Whereas if I am giving the talk to the industry, they know more about IEEE through its standards, and they are sometimes surprised that we do other things too. So it's kind of an interesting reaction I get. So I thought it's useful to put where things happen in a life cycle. In a really early concept phase, standards is not the game. You don't play the game of standards. You are trying to put a concept here, do research. Standards usually come into the picture only when you have a product to sell. You need to have something tangible that you want to take to the market. And a standard is successful when you have competitors also that you compete against, not the monopoly. Monopoly might have a life cycle, but it will die, right? So we have academic conferences where the concept evolves and then we publish. And after that, once you start publishing, industry takes over some of these research documents, and they start implementing these research in their products, right? So now we are seeing businesses evolve around these topical areas. And initially the business might evolve as a proprietary business, right? So you are addressing a target segment, you are piloting it on a market. And then what you want to do is, now you are saying that, okay, I have a captive audience, but now I want to go to market. What it means, I want to go global or I want to go national. The only way you do at that point of time is to build a standard around it. That means to say that you need a brand to support that your product is going to the brand. So they come and play the standards game. And then standards game itself is techno, political, economic. Techno because it's all about technology. Political because there are people who come into the standards domain for different reasons, right? So some of them will come to block the standard because they have a technology that might potentially be not usable if that standard goes to the market and becomes popular. So they are there just to slow down the process of standardization. And then of course it's economics. There are people who are trying to build strategies around the standard, hoping that the standard will become very popular and it will make them a lot of money. So that is the whole game. So forget this chart. I think it's a very old chart, but key is here. Wi-Fi I use quote as an example. Of course IEEE's roots are in power and energy standards, but of course Wi-Fi is the name of the game today. Everybody uses Wi-Fi, and I will have some slides to explain to you what I mean. But 2.5 billion devices are being put in the market every year. That's just incredible. That is just too much. 10 billion Wi-Fi devices that are there in the market today, and they are not seeing a linear growth. They are seeing an exponential growth on this. So that means that you can see that when Intel talks about 50 billion devices in 2020, I don't think it's such a large number. I don't think it's a utopian number. It's actually a very realistic number. And that is because today any appliance you take, it has got some kind of ICT connection. Forget the fact that it's Wi-Fi. You need any device that you buy today needs to be connected to somewhere in the cloud through some mechanism. Either it's a Zigbee or a 4G or Wi-Fi, it doesn't matter. To the simplest extent that today, I thought that this is true revolution in my opinion. When I was growing up, there are some industries called what we call as traditional industries. Textiles, very traditional. If you go to Arvind Mills, they are just milling. Today they are putting sensors inside the clothing. you know. So when a industry like textiles is embracing sensors and technology, then the game is truly out there, you know. Then you can see imagine the number of devices that you will just have inside your household, forget the overall global world. I don't know whether, I think there is some issue with the projector, but hopefully you can see that. So this is a photograph I took in Kerala, in Kochi. Anybody from Kerala here? Oh, I got one person. Usually I have one person at least. So this is in Fort Kochi, near that where the Chinese nets are. He was advertising free Wi-Fi. No connectivity, right? So there is no cable going anywhere, no router. Yeah, I'm sure he's not giving any free Wi-Fi. He's selling chai. But he thought that if he says free Wi-Fi, people will come and have chai. But that is the power of the brand, right? It's important. He doesn't understand free Wi-Fi. I spoke with him. He said, no, everybody is saying free Wi-Fi in their hotels. I'm also putting free Wi-Fi. So what the heck, like, you know? So perfect, right? So, but what I'm saying is that is the power of the brand, right? When the market accepts it. So this photo is not clear on this projector again. So these are my daughters. It was taken a couple of years back. This was actually based on when they used to live in Delhi. Here the kids have this, of course I didn't grow up here so I didn't understand what it meant, but when they start fighting they go katif. I don't know whether it's common here, right? Yeah, it's common. So they just go, suddenly my daughters will go katif. So then I will ask, what are you doing? Like, oh, I'm not talking to her. Okay. I call that as an interoperability challenge. When devices go katif, then everything will break down, you know. That's why we need standards. We have to make sure that the devices don't go katif, okay? I apologize for this picture again, but anybody can identify this movie?
Rush Hour.
Rush Hour. But hey, you attended my last talk, so you cannot guess. Anybody else can tell me who these people are in the Jackie Chan? This is amazing, right? Like I've done this slide about 100 times, right? You know, maybe this is another first time. The people nobody can see, they can guess his name. The people that everybody can see is just some American. Okay. So it is Jackie Chan and Chris Tucker, Rush Hour, right? So I don't know whether you saw this movie, but he is having a problem exchanging information with this guy, and he says, "Do you understand the words that are coming out of my mouth?" Right? So it's all about interface. You know, it's all about how you communicate, what kind of protocol you use to communicate. You don't have to necessarily talk the same language, but you have to have a medium by which you exchange information. So I thought with that background, I thought what are standards, you know, built on those pictures. It's about establishing consistent protocols and ensuring compatibility, interconnectivity and interoperability. I think that is really today's game. You cannot build, you know, if anybody is planning to be an entrepreneur here, it's really important that you have to ensure that not only you are thinking about what your device is doing inside your device, but how your device is going to be used in the ecosystem and what kind of protocols you will be using to connect to that ecosystem. Because based on that, you might have to make some interesting decisions. What kind of ports you will allow? Is it going to be a Wi-Fi? Is it going to be wired? You know, today Ethernet cabling is not even coming in our laptops. Have you noticed that? There is no longer, at least in the Apple, there is no Ethernet connection. You know, they assume everybody will be wireless connected, and then they have this separate dongle to connect to the Ethernet. But then that helps international trade. That means that you can say that, hey, I comply to this XYZ. The person who is trying to purchase your product, building a bigger product, is saying that, okay, now I understand what kind of information I can kind of receive from you, so I can make a business with you. You know? So that's very important to understand and make these decisions. We have a very open process in which we develop standards, and you know, I won't go through all of them, but it's all about consensus building, right? So the reason I want to stress on consensus on this particular point is, on this particular slide is, you have to understand when the people who are coming and developing standards in a standards working group, they are all competing in their day jobs. That means you have a Juniper, a Huawei, and Ericsson. They are all coming together, sitting at the table, sort of collaborating to come up with the standard, but outside that working group, they are actually competing on their products. So I think that's where consensus becomes very important. In IEEE, we don't define consensus as 100% agreement. We will never have 100% agreement in a working group. So we have certain rules on where we say, okay, we are good enough to publish that particular standard. Okay. And some people have told me that you know that you have a good standard when you have made everybody equally unhappy. Okay, so not one party goes home happier than the other party. Okay, so then that is the success criteria apparently for a good standard. You know, and the consensus is interesting because I graduated out of Indian Institute of Science, Bangalore. Okay, and I'm so glad I graduated. Okay, it was cutthroat. You know, I was thinking I will never graduate from that. So there were a few students. We used to decide. I don't know how many people stay in hostel here. Okay, there are a few. Okay, so we used to all stay in hostels. Most of them, at least in ISC. And at dinner, they will decide suddenly they are going to a movie, right? There will be two people who will be nervous going to this movie, okay? Because there are a couple of people, they are not sure whether they will come to the movie or go to the library and study, right? So after dinner, if they don't see those two people, you can't find these other two people also. You know, they would have vanished, like, you know. So for them, 100% is the consensus. Everybody has to come, you know, to make a decision. Luckily, we don't define 100% consensus. We have much more saner way of doing things. We have a couple of other products. Mainly we do standards development here, but we have pre-standards and post-standards, just 10 seconds each on that. Pre-standards is where we bring a community together, where the community doesn't know whether standards is what is required, but they kind of brainstorm what is required for that particular emerging technology. Post-standards is where you ensure compliance, you know, like BIS Mudra, you know, for gold. You have that BIS Chapa, right? So similarly, you just say that what is BIS telling that gold is actually the real gold, right? So similarly, IEEE puts an IEEE certified to say that that product has actually complied to the standard that it's supposed to comply. Not all products go through that. It's again market driven. Wherever we need it, we get it. For example, you will see some of the phones when you buy, you will see the Wi-Fi logo or the Bluetooth logo, right? So that means that the Bluetooth has certified that the chip inside supports actually Bluetooth. That's what it means. So this is an interesting slide. In IEEE, we have a lot of societies doing a lot of work, but there is one community called Future Directions Committee, which is looking at emerging technologies. What are the challenges that are going to be faced by engineers, maybe 5-10 years down the road, and what should IEEE be doing about those things, you know? So they are working on some really interesting stuff, you know, some of them I don't fully understand also. Smart materials, of course, you know, it's becoming very interesting. They are trying to do bendable materials so that your phone can bend if you are putting it in your pocket, as you said. They are doing all sorts of interesting things with the dielectrics. And then they are doing this IEEE Brain, which is talking about brain computing interface or brain machine interface and what kind of activity is going on in the brain, you know, a study of the brain basically, and converting it into a big data digital problem, right? And then that particular initiative is pretty closely connected with IEEE digital sensors. So this is the science aspect of it, the neuroscience aspect of it, the brain initiative. But this is more the application aspect of it, right? So when you have this data, how can you project this data through technologies like augmented reality? You know, how can you project that information and visualize that information to your eyes? So very interesting stuff. Rebooting computing, they are fundamentally defining how computing will work in 20 years from now. That's why they have this interesting name called rebooting computing. So you can see that there is a lot of interesting initiatives, and joining any of these initiatives is for IEEE members, it's free. So you can just go to your profile, select what initiatives you are interested in, and you will get the information about it. And based on your interest, you can engage or disengage as you feel like. And it's a 3-year incubation program. After 3 years, they graduate. When they graduate, that means that they have to figure out how to sustain themselves. The board will no longer support it through funding and other means. Similarly, the Future Directions Committee in IEEE standards, under my senior director, I manage a group called Emerging Technologies, and we have a whole bunch of emerging technologies that we are looking at. Smart glasses, for example, is very interesting. Anybody working in the area of augmented reality here? So anybody who knows what augmented reality is? Yeah? Okay. So augmented reality is basically outlaying digital data on a physical world, right? So how do I put it? Like people watch cricket, right? So in the cricket, when the leg before happens, they kind of do a digital display of where the ball pitched. So they have actually the physical world information of the pitch and the stumps, and then they outlay digital data where it pitched out, it's going to hit the stumps. So that's kind of like augmented reality. You are augmenting the information that is out there with extra digital information. Anybody who has seen Iron Man here? Iron Man, you have seen? Yeah, Iron Man is a very interesting movie because I was hearing a talk given by the art director of Iron Man, the guy who did the whole Iron Man when he's wearing the mask. You see a whole bunch of numbers that are coming. That's basically augmented reality. That means that he is seeing the physical world, but it's giving him information about the physical world in a set of numbers. And what this art director said was, the director of the movie, the producer of the movie came and told the art director, don't mess up with my hero. I'm paying a lot of dollars for people to see his face. I don't want them seeing a bunch of numbers. Okay, so it was he had to do a very tricky job where people are able to see, what is his name, Robert Downey. Yeah, but at the same time, be able to explain the digital. He said it was very difficult to do that because people are paying for the face, you know. If it is just a bunch of digital number, I don't need to pay him, like, I'll just put a mask, right? So, but the augmented reality is really having a very big play. Today, if you go to museums, and some of the museums in Tamil Nadu, they are really augmenting the history. So basically, you will have an augmented reality QR code. If you have a glasses, you can basically, they kind of bring the history to life on what happened at the historical site. Amazing stuff. Yeah, you had a question? Oh, you just raised your hand, I thought. Yeah. So one of the things that people are doing when it comes to augmented reality is for pole inspections, you know, when you have electricity lines, when there's a major storm, they want to know what is the problem. They don't want to put a ladder, go up on these poles. They are using these glasses to understand. In Finland, they are using augmented reality to actually verify design of ships. You know, so these are complex designs, right? If you search for an article on Boeing, okay, Boeing and augmented reality, you will see one very interesting article. Boeing did an experiment in Sheffield, right? So they were assembling this wingspan design for this Dreamliner, and they were putting the Dreamliner together. So they had two groups of people. One was a bunch of Boeing experts, okay, who have been in the field for 20 plus years doing wingspan design. And then they got a bunch of novices, aerospace engineers, gave them AR headsets and had an AR tutorial on how to put the wingspan design. The guys with AR did better than the experts. That is the power of technology, you know. It's an incredible tool, augmented reality. I think it's coming sooner than what we think it is. So why should you be interested? You know, there are different reasons to be interested. Standards are part of an industry, you know, of IEEE that draws your industry interest. That means that if you are engaged in IEEE standards, you will be connected to a lot of industry. You know, that's one quick way to plug yourself to the industry. Also, they tend to join just for that. You know, they don't care about all the other things in IEEE. They join just to develop standards and push that technology out into the market. It also means when new standards come up, it means new communities, new collaborations, and business development opportunities. It's all about networking, right? The business happens not just at the table, but on the sides of the table. And different people participate for different reasons. Some participate to learn. You want to get into an area, the best way to access experts is to join these working groups. And then as they learn, they contribute. And eventually they say, okay, they feel confident enough, they have been in the industry for a while now, they start driving and, you know, they take leadership roles. So I will talk next 10 minutes on the on the IoT. I don't think there is anything interesting that I have to say that you already do not know, but this number is quite staggering, right? Annual compounded growth of 20%. I don't think any other industry has seen that kind of a growth. Amazing. But what does IoT mean to different people? Like, you know, it's like the blind man and the elephant, you know, and it applies to a lot of these emerging technologies, whether you talk smart grids, you know, what does smart grid mean to a person, right? For some people, it's all about renewable energy. For some people, it's all about smart meters. For some people, it's about distributed automation. So it depends on which industry perspective you take. Similarly on IoT, right? So if you look at, if I have couple of slides, you know, this one and perhaps this, if you look at a view of IoT, for different people, it means different things. For some of them, it's all about industrial automation. Industry 4.0 or factory automation, smart factory. For some of them, it's all about wearables. You know, how can you connect your Fitbit to a cloud, access it into your computer, do all sorts of interesting things, exchange information with your physician. So for some people, it's it's all about energy, right? So today utilities come to us and they say how can they automate their utilities using technology like IoT, And we were trying to hire an IoT expert. We are building an educational platform, and we received a resume. It's a 30 years experience in IoT. I was surprised. How can somebody have 30 years experience in IoT? The technology itself has been only for perhaps 5 to 6 years. But that guy said, and he has a correct point of view. He said, I've been working on Wi-Fi for 30 years. And if you look at IoT, a lot of IoT is being driven by Wi-Fi, right? So he just said, he's just adopting his resume to the market, Whatever the market wants, he's just putting the right names. So, and I don't think there's anything wrong with it. Who is the best person to market yourself? It's just you, If you can't market yourself, you can't expect others to market you. But it's all about closing the loop. As engineers, we don't like open loop system. We like closed loop systems, right? So, it starts from sensors. It has an actuator. Something is happening. Then when something happens, you sense. Then you collect the data. You analyze the data. Once you analyze the data, you make decisions on the data. That is closing the loop. And I have few slides on making decisions on the data when it comes to software-driven decision-making systems, or what is called as artificial intelligence, or autonomous systems. I have a couple of interesting slides on that. When I will talk about it when I come to that. But anybody working on AI and autonomous systems and stuff like that here? I saw that outside of I was taking that. What is that building called? Faculty residence. Yeah. There is a park outside there. Somebody was playing with drone. Actually, I was running late. Otherwise, I wanted to ask him what he's trying to do there. But they were doing some experiments with the drone, which was pretty interesting. So today and the other, there is a lot of interest from various societies within IEEE to participate in IoT, but it also reflects on how we develop standards. When we develop a standard, we ask people who are all interested in this particular standard, and we get such a wide variety of response. So it's almost becoming difficult to do a standard because the views are so varied, right? Somebody is coming from a ICT world, somebody is coming from a power world, somebody is coming from an automotive world, and they are all coming with different requirements. How do we come to a consensus when they are coming with such diverse backgrounds? So one of the things we try to do today, and I think we see this as a platform going forward, typically more and more complex macro systems, as a first standard we do is establish an architectural framework. Okay, is there a framework that allows all these verticals to integrate? And then we look at the integral vertical, integration, the vertical integration, and then focus on each of the different verticals. And I talk about it in a minute on what I mean by that when it comes to some of the standards we are doing. So I said 50 billion devices, yeah. So we know that it's going to happen, but it's also the many application domains. I talked about really, new domains like textiles, transportation, everybody. Uber is amazing, like fantastic. Today I can say that that dude is going in the wrong direction. Why is he going there? Why is he not coming towards my direction to pick me up? It's amazing. Complete information is there. You can call him up. You can exactly spot people where people are. Sometimes we take it for granted. A lot of people say, when are we going to become a smart city? And I always tell people we are already in the process of going there. Today, I don't do things that I used to do 10 years back. You don't queue for a movie, you don't queue to pay a bill, you don't queue at all today. I can't imagine where you queue unless you want to queue, so I really don't see that happening, and that is the power of the digital world, right? So, and then there are different business approaches, people are making very interesting applications and how to make money on this kind of new way of working. So we have a standard called IEEE 2413. It's a standard for architectural framework. So as I said, right, so we are developing an architecture at the top level. Yeah?
So is there a device that adheres to this?
Excuse me? Yeah?
Is there a device that adheres to this standard? Is there any device that actually...
Okay, so this standard is going to be published at the end of this year.
It's not published, there's no devices right now operating on this.
I didn't say that yet. Okay, I'll come to that. So when you have the word P, that means it's a project. So typically when it's published, we kind of drop this P. Okay. But having said that, there are companies participating. There are few reasons why companies participate in the standard. They are not waiting for the standard to come out to actually make their products. Okay. They may not say today that their product is 2413 compliant, right? But as they are participating in the standards development work, they are also developing the product on that standard. It's not a serial way of workflow, it's parallel. And sometimes what they do is and it's good that it's parallel, because when I was on a standards working group, I will know that some of the things don't work. When I go and try and implement it in my system, it is impossible, it won't work, or it will be it will be very cost ineffective. Then that information gets fed back. Sometimes it's good to have this live testing happening of the implementation of that particular standard.
Does that also mean that how do you decide what you need for the implementation? How much to...
That's a very interesting question and very difficult question to answer, right? So yeah, so there are, okay, I will give you a couple of answers to that. In IEEE there are 3 ways we develop standards. One is when we call it a standard, that means that any requirement in the standard you have to adhere, okay? Then we have a recommended practice. So in the recommended practice, what we say is there are 4 ways to do things. But IEEE, the working group, recommends one way, and they will also document the other 3 ways, right? And based on your situation, you may decide you don't want to use the IEEE way, you want to use the other way. Then we have something called a guide, where the IEEE doesn't know which is the recommendation. So that means that these are the various ways to do things, and you kind of go and figure out which one fits your system, right? So that is one aspect of it. The second aspect of it, in the standard itself, there are certain mandatory requirements. When they use the word shall, that means you cannot break that requirement. And there are some non-mandatory requirements, right? And based on when you are building the system, you can decide whether you want to be compliant or not to all the requirements or only the mandatory requirements. You can say that you are compliant to the standard as long as you meet the mandatory requirements. If you decide to skip some of the mandatory requirements, you cannot say that you are compliant to the standard. But again, you can, marketing wise, you can say it, but if there is a certification program that goes along with that standard, you will fail that certification. So it's very difficult. Sometimes they debate, one community will say, I don't want this as a mandatory standard, it will not work in the environment. And that is why it's important for all the that's very, actually your question is quite deep. I don't know whether you realize that or not. It's very important, that's why all the communities to be heard. And that's why I stress sometimes Indians should go and participate in these global standard development, because a lot of times what happens is when you are adopting the standard in India, then you realize, hang on, there is never going to be minus 50 degrees centigrade here. The standard would have defined, for Minnesota it will be minus 50. Who cares, right? You are putting the transformer on the ground in Vizag or Bombay, never going to be minus 50, maybe in Ladakh, right? So you have to have your voice heard. Otherwise, things that you don't want in a standard, you will be forced to either figure a way around it, or it makes a much more difficult problem.
And this parallel implementation helps to decide.
Absolutely. And that when you are inputting your voice, you also see whether whatever they are saying makes sense or not. Totally. So this is the verticals I talked about. The framework is basically, and this is just a touch of the verticals, all the verticals that you can think about. And the idea is to build an architecture and understand what is unique to that particular domain, what is not unique to that particular domain, what are the shared concerns. Can the architecture reflect the shared concerns that the vertical doesn't have to worry about? That's the whole idea of bringing that framework around. And then, for people who are in software, anybody who does software here, yeah? C++ or something, object-oriented. So it's very object-oriented, rational growth kind of a model where you have a base class and then you inherit based on what your base definition is and make some tweaks to your inherited classes. So that's what they are basically depicting here, where you kind of have a common framework and then you have some derived frameworks for each of the verticals that you're talking about, right? In fact, the funny thing is they spent about 6 months in defining what a thing is. Come on, right? So, you would think, that is just go and look at dictionary, right? So, luckily I didn't say that, I wouldn't be working for IEEE if I had said that. But they really wanted to nail down what is the data model that they should define when a particular object is declaring itself in a framework, so that when the framework can identify, this is something that they acknowledge, right? It's an handshake mechanism, a lot of debate on you don't want the data model to be too bloated. You don't want it to be too simple, that it can make some identification. So it's a dancing game there. So, and you can see a lot of interesting companies. One I like to highlight is Finger Food. They are doing food IoT. A lot of apps today you see, Order My Chef. All sorts of interesting things are happening on the food world. Yeah, sir.
Basically, what you mean to say, the basic protocol stays the same, depending on the application you smart city or something like that, smart company.
Exactly.
You add on to that.
It's not even the protocol. We are not, the architecture is not looking at the transport layer, right? It's looking at the application layer. At the application layer, so the protocols are already defined or being defined. It's your 802.11, your ZigBee, your 4G, whatever. At the application layer, when the applications are coming together, what should be the framework? And then what are the derived applications for the different verticals, you know? So, because transport layer, it's being addressed separately, you know, that's a different problem by itself. And I talk about it also. So that brings me to the next slide. One of the things, yeah, go ahead now.
Just wanted to ask, Google's not participating, Samsung's not participating.
Yes.
They're major players in IoT.
Mm-hmm.
Don't you think that's going to be a bit of a
It's a good question. So it's an open participation. We don't force people to participate. What we do is whenever we are in California or in Korea, we go and meet these people. We tell them what we are doing. It is possible that they are working on a technology that is competitive to this technology, and that's fine. It is possible that they understand what is happening in the technology because some of the components they are hiring from a Qualcomm, they are hiring from NXP, you know, like Samsung is not building the whole system, right? So if they have the right players participating in these groups, then they don't have to worry about it. It depends on at what orchestration level you want to participate, right? If you are at the chip level, you are worried about IoT, but you are sourcing your chip from Qualcomm. If Qualcomm is there, then they don't care. But having said that, I feel that they should also participate. Perhaps they don't know the success of this standard, so sometimes they will wait and watch, right? They will do a proprietary model. And see, these are all behind the scenes, right? It's not like an 802.11, this is the architectural framework. So the next version that they will release, they will migrate to this platform. So there are various ways companies think about it, but I agree with you at the fundamental level that Google and Apple and Samsung should be here, but they are not. 1451-99 is a good standard where we are looking at the harmonization of protocol. Like it's a challenge of the weakest link. Today a lot of protocols, let me finish this point and I will come to you. A lot of protocols are coming together. Some protocols are very old protocols, security is very weak. Some protocols are very strong protocols, and they are all in the same system. What do you do, right? So one of the things they are looking at is for people who understand digital certification, they are looking at X.509 as a way of authentication of devices, you know, when they are harmonizing these protocols. Yes, sir.
Why did it take too long
You have to talk a bit loud because I'm having the fan here.
why did it take too long to come with this standard?
To come with which standard?
IoT standard.
Why did it take too long to come with an IoT standard? Okay, wow. So it takes typically 4 years to take do a standard, you know. Why does it take 4 years? I have a separate answer. So this standard started in 2012, the 2413 or 2013 roughly, okay. It takes that much time to build consensus. Develop a product and get consensus is not it's much more difficult because you have to understand there are two reasons. Standards is secondary job for a lot of primary job owners. You know, they are working their day job and then they are building the standard. That means the working groups meet once in a month. So you can imagine if you are putting effort once in a month to develop that has a slow pace. The second reason why standards don't develop typically fast is the return on investment is very expensive, right? You know, if you are running a business, you have a standard, you have developed a product to a standard, then you want to recover the money R&D that you have invested to build that standard. Let's say they come and say, hey, hang on, like in 6 months time, we have a new version of that same standard. They will say, what the, like, you know, I haven't even required money on that, now to put more R&D on this new standard, like, right? So they kind of control it, right? So the industry players come together, they kind of pace it out so that they kind of recover the money. So it's just not about technology when you come into these games, right?
Sir, I'm asking that the technology is
But you have to understand, only in the last 4 years or 5 years, things have come together. 5 years back, you know, we as humans, we are very good at forgetting pain, right? So 5 years back, we did a lot of things very differently. You know, now we are used to the Uber. Uber hasn't been around more than 3 years, you know, in a productive way. Until then, we are catching autos, right? Arguing with the auto driver, right? So that used to be our life. But what I'm saying is only 5 years time, people have come together and started evolving these systems, right? And it takes, IEEE was also a bit late, in the sense, wantedly late. We didn't want to jump into an IEEE IoT standard just because everybody else is doing it. We wanted to understand, we spent about a year to figure out what the gap was, and we identified one of the gaps was there is no tie-in at the architectural level when people are developing these vertical systems. So that's why we started this work in 2013. Yeah. Go ahead, madam.
Last one, just support the other people who are also making standards.
Who are the other people? Okay, I just deleted a slide from this deck because I thought that won't be important. So there are about only 100 other organizations. Okay, ISO, IEC, JTC1, 1M, 2M. I don't know, industry consortia like Thread, Industrial Internet Consortia, OMG.
You have to market your standard also.
This is a very complicated, I don't know, I'm running out of time here. So, since we are doing Q&A, I will go till 5 and we'll close, okay? Yeah, okay. So, we create liaison relationships. So what happens is when you are creating a standard, they all kind of know who else is working on that particular standard. So they will send a liaison to that standards working group to exchange information so that we are not duplicating effort. At the same time, we are understanding what each others are doing so that when they are releasing their platform, it is plugging into our platform, right? But that is very utopian. We try to do it, we want to do it, we put a good effort doing it, but sometimes it doesn't happen. So, right. I had a slide on it, I kind of deleted it. We are doing one on, so this is interesting. So in the IoT there is a lot of play of words, right? So there is cloud computing. People have heard of cloud computing. Now who has heard of fog computing? Okay, one person. Okay. Edge computing? Okay, same person. Okay, because both are same. So fog and edge computing, what they are doing is, so what happened was when they moved from servers in your own office, back office, to the cloud, they just changed the problem from CapEx to OpEx, for people who understand business. So instead of capital expenditure buying the instrument, now they were paying the telco providers, transmitting huge amounts of data between your application to the cloud. Became very unmanageable now in the era of digital data. So what they did was, now they have a term called edge computing, where it's called computing on the edge of the device. That means that not all the processing is happening on the cloud. They are trying to move some of the processing on the edge of the device, okay? And then move some of the non-essential work on the cloud, right? So they are trying to do a balancing act of what they push on the cloud and what they will push on the device. And based on the play of word, we thought we had a fog, we have an edge. We came up with the concept of roof, right? So, but it has a technology meaning too. It says real-time on-site operation facilitation, mouthful. But what the roof computing does is basically, we were looking at in-building Internet of Things, like for example, hospitals, airports, like hospitals is a very classic case. How do you have an entire hospital just connected within itself, like provide a Wi-Fi connectivity between the nurse to the patient to the doctor and have an hospital ecosystem running, and they are defining some protocols which is actually piggybacking on what is happening on 2413 and 24010, right? So basically they are defining a framework and APIs for providing these kind of facilitation within in-building premise. Very interesting work that is doing. And the good thing about this is being driven out of India actually. The working group chair sits in Bangalore, and about 50% of the team is from Bangalore and Hyderabad. So people are interested, please do join because it will be at a time that you can actually participate. 2418, anybody heard of the word blockchain? Bitcoin? Okay, that's good. Bitcoin, a lot of people have heard. So blockchain was a technology that Bitcoin used, right? So basically it means distributed ledger. Like people use Google Docs. So it's kind of a distributed ledger. So you have a lot of copies and a lot of servers. People are simultaneously modifying the document, and then there's a final clean version. So blockchain is now becoming really popular. Previously blockchain was only tied to Bitcoin in fintech world, right? That was its only application. Now its application is becoming into the technology world where they are using blockchain in the pharma, in health. The reason they are doing that is supply chain is becoming a real big issue. So there was recently a $13 billion case on counterfeit cancer drugs. So there was cancer drugs which was coming from the Middle East that was fake, right? It has two problems with the kind of an issue. One is the economic problem, people are losing money. But the second problem is a health problem. You are putting counterfeit medication for curing cancer. So blockchain is now going to be used to manage the whole supply chain, where you can kind of monitor from production to the use. And I was in Australia a couple of weeks back, and they are looking at the exact same problem, supply chain, but for beef. Now they are supplying, Australia supplies a lot of beef to a whole lot of world. You know, apparently they are supplying beef to McDonald's. That's a lot of beef, right? So they are saying that there is a lot of fake beef coming into the picture. So now they are putting blockchain. So food industry is now using technology to kind of manage the supply chain process. So one of the challenges with the Internet of Things people might hear is security and privacy. You know, people are always worried that you know, how are we going to make things secure? And that's a real big problem. I don't know the answer. I don't think anybody has a very clear view of it. But blockchain, they are saying, is one of the ways to do it, because you have to really go away from a client-server model. You have to go to a distributed model. You know, client-server model is $50 billion. That's not going to work, right? So. 2510, another interesting standard on sensors, and anybody working on sensors here? Okay, so that's good. There are a few people on sensors. It's on establishing a quality of sensor data. Now, if you look at a lot of applications, industrial applications like mining, even autonomous vehicles, you know, if you go to a lot of airports today, all those trains are all driverless. There is nobody sitting on the front of the train. They are all becoming autonomous. In that world of autonomous systems, you have to ensure the quality of the sensor data is accurate, because your system is making decision based on the data that it is receiving. So there is a program that we have put together on real-time analytics on 2510, and we are also planning a certification program to ensure that those devices are, because these are all critical applications, you cannot assume that the manufacturers are compliant to the product. You need a kind of a third-party certification. So this is a listing of some of the IoT standards. I won't go through all of that. This deck will be available for people who are interested in doing this. Okay, and this gives you answers part of your question, madam. Like, you know, today if I have to put a slide of every IoT, SDO, Standard Development Organization, industry consortia, there will be about 1,000 easily. Okay, so these are some of the groups that we kind of work with within our partners or license relationship. You know, you can probably recognize some symbols, not recognize others. I want to touch on security, right? At least when I was doing VLSI design donkeys years ago, you know, security is just after the thought. You know, somebody will find a problem saying that, hey, you know, you have a security problem, then we'll try to go and put some fix to it. No longer it can work like that. You know, everybody should care. In fact, today there is a statistic that says that on the hardware projects, 58% of security features. That means the functional features are only 42%. They are more worried about the systems getting hacked. You would have heard about the hack of the cameras that brought down Twitter and a whole bunch of big data servers. That happened about a year back, 6 months back. You know, they hacked into every camera because the camera did not have any kind of security protection, and they just brought down the entire system in the US actually. So I like this particular law of cyber security. It's kind of interesting, you know, though it's obvious, everything that's connected to the internet can be hacked. Everything is being connected to the internet. So, you know, and the third law derives from the first two laws. So, you know, so you have to kind of understand where we are going with this, right? So, and these are all actual news feeds you can actually read when you get this deck. Very interesting stories. I will skip this slide. I will talk about this slide. Okay, I think this is very important. When I was doing verification on a chip, I had to verify only the functionality of the chip. That means that somebody gave me a functional spec. I had to say that, okay, my chip is working towards a particular functional spec. Today they are redefining the problem. Of course, this is not practical, but you know, if you are trending in the way, verifying that the chip is not doing what it's not supposed to do. How would you do that, right? And that is the problem of security, because how can you imagine all the, I don't know, infinite use cases? People will always have a use case that you have not thought about. But really the problem, it is just to highlight how complex the problem of security and verification is. I don't care much about this slide, but okay. So now I talked about some of these standards, and here in the next few slides I will talk a bunch of verticals. This is not interesting, but we have a whole standard on intelligent transportation. how when drones are really going to come into picture, how will the drone communicate to the architecture, how will the drones communicate with other drones. So it's what we call as V2V, vehicle to vehicle, or V2X, vehicle to any infrastructure, X being anything. There's a whole family of standards called IEEE 1609, wireless access in vehicular environments, very interesting standard for anybody working on the transportation side of things. And if you expand that, I really feel bad that the slides are not coming out well here, but hopefully it will look much better in your laptops. We are having a whole, now if you look at anything, it's all connected systems, right? Today, if you go to, anybody flown Emirates recently, they have Wi-Fi apparently in the airplanes, it's amazing, So that's one place I thought that you don't have to do work because you cannot. But now your boss will say, can you respond, because you are connected to Wi-Fi, incredible. So we are really looking at a connected environment, and there's a whole bunch of standards that goes on the transportation side of things. And then we talk about smart energy, and there was one thing I wanted to talk about smart energy is IEEE 1547. 1547 is how you connect your microgrids to your electric power supply, so people are doing a lot of DC microgrids. Anybody working in power area? Nobody? Okay, you half raised your hand, So, but it's, today it's important, right? Even if you're a software engineer, you need to understand a couple of other domains. I will tell you a very interesting joke that happened. It's a joke now, but not joke for the utility that went through that experience. So, application developers were out, software developers, and they were developing a financial accounting package for a utility. So they were developing the software, and the utility deployed the software, and they were losing money, and they couldn't figure out why. This was a utility in the US. They couldn't understand why they were losing money. And then they realized, it took them 2 years to realize this. The software engineers who were developing the software, they were thinking, okay, what is 1 kilowatt? 1024 watts. What is 1 megawatt? 1024 kilowatts. They just put 2 power n everywhere, It is just, just incredible, right? So of course the computer compiler didn't pick it up. Nobody picked it up, right? It is just a bunch of numbers. And then it got all published, QA'd, and took them 2 years to figure out that they didn't realize that 1 kilowatt was only 1000 watts. Not 1024 watts, So you kind of half raise your hand. So when I ask people that, you should always be worried about the domain you are working in. You can be an application engineer, but tomorrow you might be working in a domain. So you are better off knowing a little bit about who your customer is and what they want. But that was a digress, 1547. So now everything is becoming DC driven in our world. If you look at modern buildings today, I hope in that building that you are building, you are putting on LEDs, not your regular lamps, right? So they are all digital driven, DC driven. What it means is your power consumption is almost reducing by a factor of half when you go from AC towards DC. But what it also means is you are now getting a lot of interesting technologies. It's very interesting because, and this always amazes me, on one side we have this 1901 standard that I'm talking about here. 1901 is where, since you have power lines going, there are companies thinking that, not thinking, already have products, on how can I transmit broadband over these power lines? How can I send data over power lines? Noise was an issue. They have solved that noise problem. Now it's pretty much commercial. So 1901 talks about a technology called BPL, broadband over power line. And on the other hand, there is a technology called PoE, power over Ethernet. Now you have a lot of Ethernet. How can I send power on these Ethernet lines? And our IEEE office in Bangalore actually uses PoE cables. So our calling bell, emergency lighting, they are not coming from the utility. Actually, it is driven by the Ethernet power. So it's quite amazing. Your biometric card scanner that you see in companies and all, as you enter, you have to scan, right? They are all not utility powered supply. And today the power over Ethernet can supply close to 80 watts. If an LED bulb is maybe 18 watts, 12 watts. So you can kind of imagine that you can pretty much run a small home with just Ethernet power. So now you have new business models where suddenly your network operator might think, I can sell power. Right? So it's interesting. Oh, what happened there? Sorry about that. I will wrap it up in 5 minutes. Okay. E-health, point of care devices, Fitbits, we seem to be transmitting everything to the physician, how many people have Fitbits here? Okay, I'm very worried about having Fitbit. I'm worried without knowing the numbers. If I see the numbers, my numbers will become even worse as I see it, so I never understand why anybody wants to have such monitoring, but again, a lot of companies are built around it, so I shouldn't be saying these things, I'm devaluing companies. But anyway, so it's about monitoring, but these are more important, when you're in a hospital, your doctor can remotely monitor, he can address the patient's problems, and we are mainly looking at non-clinical point-of-care devices, but we are also coming into the clinical space a little bit as we speak. And this is basically connecting your point-of-care devices, whether it's your sleep monitor or cardiovascular, to a remote physician using cloud. And what they are doing is basically building a data model on your HL7 so that you can transmit these data remotely. Green, of course I've skipped that. So basically if you look at smart homes, everything today is connected, so I don't think we are, there is already a big task force that is here in Delhi, which is looking at vehicle electrification. They are saying that by 2030, it will only be only electric vehicles. Professor Junjunwala is actually driving that particular task force. He used to be with IT Madras, now he sits with the Ministry of New and Renewable Energy. So what I'm saying is, and once you have electric vehicles, then the concept changes, right? Now, how does the utility have a play in this game? Because it's a different kind of mechanism. Your substation, it will be different kind of metering. How can you say how much goes to your vehicle charging versus your home charging? Those are typically happening in common areas. How do you charge? Who to charge when you are doing it from a common area? Very complicated. But already the business models are already being sorted out. And 5G, 5G talks about, it's a little bit out of the game, 5G today, but we are talking about mobile edge computing, soft RAN, soft RAN is interesting. Now we are going towards software defined everything, right? So nothing, when I was doing designs, who works on DSPs? Anybody? Digital signal processors? So DSPs used to be a hardware, when I was working, it was going through this transitional phase where DSP became from a hardware to a software. And you have to make a hardware-software partition when you are doing IC design. And the reason you will partition that is, you will have to decide what is your parameter that you care about. Do you care about performance or do you care about cost? If you care about performance, then you go hardware, because you cannot beat the speed of the hardware. But if cost is a factor, you go software. So now you have to make a decision like that on almost every aspect, because there is a software-defined everything. So you have to make a decision on what you are going to build in your system. And this is just encapsulating what I talked about in a very nice graphic. If one takeaway you have is probably this graphic, which basically talks about what are the different verticals in a smart city and what are some of the key stuff that IEEE is doing. I'll take 2 minutes for some of the other considerations and stop. So what are our other considerations? We talked about security, we talked about business, we talked about interconnectivity, interoperability, a little bit on privacy perhaps. So the idea of IEEE is the advancing technology for humanity. So what is the human angle here? So one of the things we started was an initiative called ethical consideration of in artificial intelligence and autonomous systems. Okay. The idea is now when you are building autonomous systems and when you are going through a software-driven decision model, how does the ethics apply? That means that let's say you are in a driverless car in an accident scenario, should the software work in favor of the passengers of the car, or should the software work in favor of the passengers on the road? Whose life should it save in an accident scenario? Very, very philosophical but very complicated question. And it's very important to solve these questions, because tomorrow you have to also figure out who's to blame. Not that is the whole idea, but you have to figure out predictability of a system when you are going to software-defined systems. And ethics is extremely important part of it. So we built a document called Ethically Aligned Design. And it's a very interesting document. It's something that IEEE has never done. But I think that IEEE felt very strongly about, especially as you take the human element out of the decision making, how can we still ensure the human concepts are still built into the systems that we kind of build. So they did an ethically aligned design, version 1. And the idea was to basically release this and take a public input. So they did an RFI, request for inputs, and it was freely available, and they got about 1,000 odd comments. And there were about 160 people who participated, and we had some demographics, but it attracted a very diverse audience. It was quite amazing, the kind of people who kind of came to the table and wanted to understand what are the ethical considerations of these kind of programs. And now they are working on a version 2, and I really feel that we should really engage in this, because we are going to face this problem more and more, because everything is going to be, the way we will add value is at a different level, the fundamentals will be at a lower level. So I think that these are open platforms, people can come and participate in it, and there are a bunch of standards projects that they have already started. These are all open standards projects, data privacy, in fact there is something about children, standards on child and student data governance. A lot of students use mobile applications today. They sign up to a lot of different applications, right? So, and they agree on all these terms and conditions. So what does that mean? Are the companies doing ethically something correct or incorrect? And people misuse data, you don't realize it, but people misuse data. Algorithmic bias consideration. Is the algorithm biased towards one aspect of it? So it's very interesting work. I think people should take a look at it and see if there is anything that piques your interest. And with that I will close actually. So
We can take questions offline, I think. We already have sort of time. So let's thank the speaker.
thank you.
Thanks for such an interesting and exciting talk.
No, I couldn't finish it, but you can send that deck. Yeah.
Thanks, this is
Thank you. Oh. No worries. You are monitoring me now,
Yeah.
whether I'm using your mug or not.
You can't trust human beings, so you have to.
Yeah, sure. Thank you.
Thanks. If you have any questions, you can take offline.
Yeah.